Hey everybody, this is the same question that I solved in class today, but if you missed it, I'm going to go ahead and solve it here, and then I'll take a look at questions 2, 3, and 4 as well and put those up as a possible chance for you to learn how to handle coefficients of friction and forces and how these things all roll. So this first question that we're looking at here is a question that involves a trunk that is being pulled across the floor. And it reads like this. It says a horizontal force of 400 newtons is required to pull a 1,760 Newton trunk, that's its weight, right, across the floor at a constant speed. If it's a constant speed, it means it's not accelerating, and therefore all the forces must balance out. Find the coefficient of sliding friction. So this is what we're looking for in the end, is the coefficient of sliding friction. So I'm going to start this problem by putting in a free body diagram, hoping to explain kind of all the different pieces that go into it. I'm going to start out, you remember in a free body diagram, I'm going to draw a dot to represent this item itself. So this right here is my trunk. You could draw this differently. You could draw a little picture of a trunk if you'd like, but I'm just going to draw a dot to help me out. And then I'm going to draw all the forces that are on the trunk. First, the force that's on the trunk, which is on every object that's ever been on the Earth, is the force due to gravity, or the force of gravity down in this case. So pulling towards the center of the Earth. And I'm going to label that as my force of gravity, so Fg. Now, because this trunk is not accelerating, right? It has a constant speed. It means that all kind of forces have to be balanced, which means that this force has to be balanced, and it is. And the force that balances this one is the force that is the ground itself pushing back up on it. And so this equal and opposite, let's make a straighter line here. This equal and opposite force is this way, and we would call this one your normal force. Now, it is important to note that normal forces are not always perfectly balancing out the force of gravity. These are not always equal and opposite, but they are if you're in perpendicular with the surface on the ground. There's also two more forces that are going on this one. One of them is this horizontal force of 400 newtons. So I'm going to go ahead and put that one in right here. And it doesn't matter which direction that's going as long as it's horizontal. So I'm going to put it to the right here. And I'm going to call this the force that is being pulled, or my applied force. So I could put that as a force app. Then I also have, because this is not accelerating at a constant velocity, I have another force that is slowing it down or holding it back. And that other force is the force of friction. So now I have all of my forces balanced out, which is good because I have a constant speed. My gravity is balanced out by the normal force of the ground pushing up on the trunk. My applied force is being pulled back with the force of friction on the other side. All right, now we're trying to figure out what the coefficient of friction is. We only have one equation to work this. And so that one equation to work this was given in the textbook a few days ago, or a day ago. And that coefficient of friction has this symbol mu. It's a Greek letter mu. It's like a letter U with kind of a line hanging down, or kind of like a smooshed M, if you want to think about it that way. The coefficient of friction is a ratio of two forces. Those forces are the force of friction divided by the force that is normal. Now, if we knew what these numbers were, we could plug them in and we could solve this pretty easily. Well, it turns out we do know what those numbers are, thankfully to the pieces in the problem up above. It says the horizontal force, this push force or pull force, however you want to think about it, is 400 newtons. So I'm going to go ahead and put that right in here. 400 newtons is what the applied force is. It also tells us that the trunk is 1,760 newtons, which is the weight. And so I'm going to put that one right in here, 1,760 newtons. Now, we have these two, but what do we know about these? Well, they're equal and opposite. So if it's 1,760 newtons down, then it's 1,760 newtons up, right? And if it's being pulled on with 400 newtons to the right, then friction must be pulling back on it with 400 newtons to the left, because it's a constant speed. Now we actually know all four forces, and we can plug them into our original equation that's over here. And so when we do that, we can say that the coefficient of friction is equal to 400 newtons divided by 1,760 newtons. And because I have newtons on the top and newtons on the bottom, the newtons are going to cancel out, and I'm left with a unitless number, which means that my coefficient of friction here is equal to 400 divided by 1,760, which is equal to 0.23. And you might say, well, what are my units? Well, there are no units. They all canceled out. This is just a number. It is a coefficient. And a coefficient just means that it is a number. So in this case here, my coefficient of sliding friction is 0.23 between this trunk and this floor. Hopefully that was understandable. We're going to take a look at the next problem in the next video. So have a great day, and I'll see you in the next one. Adios.